Okay, so in this video and in the next few videos I'm just going to have a look at these particular series here. I've called them S1, S2 and S here. Now what's been said here is that really this one here is going to give us a half, this one here is going to give us a quarter, this one here, believe it or not, is going to give us minus 1 over 12. Now if you look at these series, now really in this particular video I'm just going to have a look at the first one here, which is S1. And what we're saying here is that 1 minus 1 plus 1 minus 1 plus 1 minus 1 will give us 1/2. Now, if you look at this, if you look at the partial sums of this, if you look at 1, you start with 1, add these two here, you'll get 0, so you've got 1 and then 0, it goes back to 1 again, 0, so it oscillates, it goes from 1 to 0, 1 to 0, 1 to 0, and so on. So how can we get a half from that? That's what I'm going to look at in this particular video. Now in actual fact these are not really equal. None of these are equal as such, not in the standard way anyway. If you look at all of these three series, they all diverge. They're not convergent series. So the limit of their partial sums doesn't converge to a particular value. So let's just have a look at the first one first and see where this half might come from. I'm going to have a look at a few different ways of looking at where this half has come from. So let's look at that first. So let's just write it out again first of all. We've called this one S1, and it is 1 minus 1 plus 1 minus 1 plus 1 minus and so on. What we can do first is just subtract subtract S1 from 1. So we're just going to do 1 minus S1 on the left hand side. So we're going to do 1 minus the right hand side as well. And so on. Okay, so 1 minus S1 on the left hand side. This is just going to be 1 minus, if I take away the bracket here, I get 1 plus 1 minus 1 plus 1 minus and so on. So this is really the same as what I started with. So really this is just 1 minus S1 is equal to S1 again on the right hand side. So bring this over here, I get 1 is equal to 2 of these S1s. So that gives me the S1 here is just equal to 1/2. So that's one way of getting S1 equal to 1/2. Let's have a look at another way. Okay, so let's just write down the series again. So it's S1 is equal to 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus and so on. Now what I'm going to do here really is just have a look at what's called the partial sums first. So let's have a look at these partial sums. Okay, so if I look at the first one here, what I'm going to do is just write down the partial sum of the first one, which is just 1. Now the second one here, these two here then, I've got 1 minus 1, that's going to give me 0. Have a look at the first 3, that's 1 minus 1 plus 1, that brings me back to 1 again. And you'll see that's just going to oscillate really, it's just going to go up and down from 1 to 0, 1 to 0 and so on. So these are our partial sums. Now what I'm going to do is have a look at the average. The average of these partial sums. So if I look at the average here, what I end up with is, well, if I average the first one I just get 1. Average these two here, I'm just going to look at these two now, so that's 1 plus 0, which is 1, divided by 2, so that's going to give me 1/2. And the first 3, so I'm going to look at these 3 here, average those 3, so it's 1 plus 0 plus 1, which is 2, 2 divided by 3, so that's going to give me 2/3. The first 4 is going to give me 1/2 again, and then I get 3/5, then I get 1/2 again, then I get 4/7, and I get 1/2 again, and so on and so on. So this is the average of our partial sums. Now this actually converges. It converges to 1/2. So the limit here is just going to be 1/2. So that's where I get 1/2 from again here. So you can see I start with 1, then I get a half. Every second one here is a half, and every other one then is getting closer and closer to a half. You have 2/3, 3/5, 4/7. You're getting closer and closer to a half as well. So the series here converges to a half. So this series here doesn't converge to a half, it's divergent in fact. So it doesn't converge to a half, not in the standard way, but it does when you look at the partial sums and then the average of the partial sums. So what we say here, it's actually Cesaro convergent. And we would say it's C1. So the first lot of averages here of the partial sums converge to a half. Okay, so that's the second method here. Let's just look at another one. Okay, now I'm just going to have a look at this here first of all. We have 1 over x, and that's going to be equal to 1 minus x minus 1 to the power of 1 plus x minus 1 squared minus x minus 1 to the power of 3 plus and so on. So we know this is true, and this can be proven fairly easily by just multiplying the left and right hand sides by x. Now I'll just do that proof very quickly for you. So what I'm going to do here is multiply both sides by x. Now I'm not going to multiply by x in this form here. I'm going to multiply by x in the form. So in the form x minus 1 plus 1. So that's what I'm going to do here. I'm going to multiply both sides by this here. So this really here is just x. So let's do that. Okay, so if I multiply the left hand side by x, I'm just going to get 1. Okay, so that's fairly straightforward. Now I'm going to multiply the right hand side here by x minus 1 plus 1. So if I multiply by this here, what I need to do is multiply by x minus 1 first and then multiply by 1. So let's multiply by x minus 1 first. So multiply this by x minus 1, I get x minus 1. Minus, multiply this by x minus 1, I get x minus 1 squared. Multiply this by x minus 1, I get plus x minus 1 cubed, and so on and so on. Okay, so you can see the pattern here. Now I'm going to multiply everything by 1. So multiply 1 by 1, that will just give me 1. Multiply this by 1, that will give me minus x minus 1. Multiply this by 1, I get plus x minus 1 squared. Multiply this by 1, that will give me minus x minus 1 cubed, and so on and so on. So if you look here on the left hand side, we have 1. Now what do we end up with on the right hand side? Well, if you look at these, we have an plus x minus 1 here, minus x minus 1 here, so they're going to cancel, or give me 0 if you like. Here I've got a minus x minus 1 squared. Here I've got a plus x minus 1 squared. So they're just going to cancel as well, or give me 0 there. And so that's going to continue on the whole way up along. And all I'm going to be left with here on the right hand side again is this 1 here. So I'll end up on the right hand side here with 1. So this here is proven, if you like. Okay, so what do I want to do then? I'm going to use this to show that our series 1 minus 1 plus 1 and so on is equal to a half, or we can apply or give it a value of a half. Okay, so if we just simply let x equal to 2 here on the left hand side, we get half on the left hand side, so left hand side we get 1 over 2. What happens if we let x equal to 2 on the right hand side? Well, we'll end up with 1 here minus, if I put a 2 in here, 2 minus 1 is just 1. Here I'll have a plus. Put 2 in here, 2 minus 1 is 1. 1 squared is 1. Put a 2 in here, 2 minus 1 is 1. 1 cubed is 1, so I'll end up with minus 1 here, plus, and so on. So I end up with my series here again on the right hand side. Okay, so that's just 3 different methods I can use here just to show where this value of a half can come from. I think there are other methods you can use or you can apply to this particular series, and you get half as well. So that's it for this particular video. The next video I'll look at what did I give it, S2 I think it was, and we'll have a look at that particular series.